The purpose of this video is to introduce you to the new precision wash dishwasher with electronic controls. Hello, I'm Paul Cordry, and today I'd like to spend a little time with you and go over the servicing and troubleshooting of the new precision wash dishwasher with electronic controls on it. Although the precision wash dishwasher with electronic controls will be built in a number of models, for the purpose of this videotape, we have broken them down into 4 categories by using their control panel. The first group of models is the electronics, and here we can identify these by the fact that the control panel has a knob that looks like a timer knob that you use to set your cycles with. Our next group of models will have the standard control panel which you're used to seeing on an electronic dishwasher. Here we have a touchpad which allows us to set the cycle and the functions of the dishwasher. Our third group of models we will call slimlines, and that is because the control panel on these models is only about half the height of the standard control panel. Here again with these models we will select the cycles and the functions by touching the touchpads. Our final group of models will have the slimline control panel, but to the control panel a digital display has been added. Now that we've broken the electronic control dishwashers down into categories, before we get into the operation, troubleshooting, and teardown, let's pause and review the water distribution system on a precision wash dishwasher. To do this, I'm going to use an excerpt from our original training tape on the precision wash timer model dishwashers, showing the pump and the water distribution and the alternation of the spray arms.
But the real ingenuity lies in how we accomplish the change between wash arms. Frigidaire engineers studied all of the alternating wash systems in the world and found that they use a variety of complex switches and other mechanical means to alternate the wash arms. Our desire for simplicity and therefore reliability led us to use one thing that can never break and will always be there when we need it: gravity. The real ingenuity lies inside this water distribution system with Frigidaire's checkball flow control system. Water is drawn into this system by the impeller. From here it can go into one of 2 directions. The path to the lower wash arm is through here, and the path to the upper wash arm here. How do we decide which way the water goes? Introduce one of the world's most high-tech, space-age, scientifically complex mechanisms to ever be used by mere mortal man: a little ball. The little ball is at the bottom of a ramp where it almost completely blocks the path to the upper wash arm. The ball will always be there at the beginning of a cycle. Gravity ensures that. But we don't completely seal this opening. We do let a tiny bit of water leak past, filling the upper wash arm tube with water while the lower wash arm is rotating. After 90 seconds, when the pump is shut off, gravity pulls all of the water in the upper wash arm back down into the sump, pushing the ball up the ramp, blocking the opening to the lower wash arm. When the pump starts up again, the water pressure that's instantly created holds the ball in place. The only direction water can travel now is to the upper wash arm. When, after 90 more seconds, the pump is shut off again, gravity pulls the ball back down the ramp to its original position, and the whole process starts over, again and again and again. Forever, because there's simply nothing that can go wrong with a little ball being pushed around by water and gravity. That's the story of how Frigidaire took some of the world's leading technology and ingeniously simplified it, creating what will most likely become the most effective, most reliable wash system in the industry.
I'm not going to go over a step-by-step operation instructions with the electronic control, but I would like to point out 2 things. First, the electronic control dishwashers have built into their cycle an automatic pause of up to 10 minutes in both the rinse and wash cycle, in which time the heating element is operated in an attempt to raise the water temperature to 136 degrees. In our cycle chart, we call this pause temp assure. Basically the way it works, the control receives an input from a thermistor located on the bottom of the pump sump, which senses the temperature of the water in the sump area. When the control reaches the pause increment, If the water temperature in the tub is above 136 degrees, the control countdown continues. If the water temperature is below 136 degrees, the control pauses the countdown, and the heating element will raise the water temperature about 3/4 of a degree for every minute. If the water temperature has not reached 136 degrees by the time 10 minutes has elapsed, the control then goes on with its countdown. If we look at the cycle chart again, you will find that the increment next to temp assure in the wash cycle is high temperatured wash, and in the rinse cycle is high temperatured rinse. These two functions must be selected by the user, as they do not occur automatically, but operate similar to the temp assure. Basically, they pause for up to 10 minutes, but instead of trying to heat the water to 136 degrees as in the temp assure cycle, the high temperatured wash attempts to heat the water to 143 degrees, and the high temperatured rinse attempts to heat the water to 145 degrees Fahrenheit. Again, we have a 10-minute maximum on each of these functions, and as with the temp assure, if the water temperature is not reached in the allotted 10 minutes, the control continues its countdown. The other thing under operations that we need to talk about is not available on all models, but is the cycles called upper rack and lower rack. These cycles were designed for when you only have enough dishes to fill one rack. By choosing upper rack or lower rack, you change the percentage of the time that the upper spray arm is on and the lower spray arm is on. If you choose upper rack, the upper arm is on for about 50% of the time, and the lower arm is on for about 50% of the time. If you choose lower rack, the lower arm is on for about 60% of the time, and the upper arm is on for about 40% of the time. The lower rack cycle is almost identical to the normal wash cycle. Troubleshooting of the electronic models, I feel, is actually easier than troubleshooting the timer models. Before we start into the troubleshooting, there's two things you should know. First of all, I would like to point out the location of the service data sheet. This sheet is basically a mini service manual and is located behind the control panel, being held to the inner door liner by a tab. The other thing we need to talk about before going into troubleshooting is called the diagnostic test, and this allows us to rapidly advance the electronic control through the cycle so that we can test each component. The service data sheet contains information on how to start the diagnostic test and also gives you a matrix on when each component is going to be operated. One thing you should know: before you can put the dishwasher into the diagnostic test, you must have it in the power failure mode. You can get the dishwasher into the power failure mode in one of two ways. First, by removing and then reapplying power. And second, if power is already applied, by holding the high temperatured wash and start cancel pad for 3 seconds. At this point, you will notice that the LEDs above the high temperatured wash and no heat dry will start to flash. This indicates the dishwasher is in a power failure mode. Then, by holding the no heat dry and the start cancel pad for 3 seconds, the diagnostic test should start. Once the test is started, by observing the matrix, you can tell when the component should be activated so that you can set up to test it. One thing you can do if the component you want to test is near the end of the diagnostic test is hit the start cancel pad twice, and it will step ahead one increment, and this will allow you to advance it faster than normal. Now let's talk about the possible failures, what components that could go bad that would cause these failures, and how we would troubleshoot these. The first failure let's discuss would be a dishwasher with electronic controls that is completely inoperative. To help us troubleshoot this, I've drawn a small schematic showing the components which would be involved with this problem. Before we actually start to do some testing, let's go over the possible components that could fail that could cause this problem. First, we must have power to the dishwasher. Next, we have a small transformer that supplies power to the board, and if this fails, it would cause the unit not to operate. The third component would be the control board. Fourth would be the touchpad. The fifth component would be the line side door switch. and of course the wiring between these components. Now, where do we start our testing? First of all, you will notice on the diagram I've drawn in the thermistor. And the reason I did this is because I know a secret. The secret is that whenever power is applied to the dishwasher, if the transformer is good and the board is partially good, you will have 5 volts DC applied to this thermistor. So therefore, the first test I would do would be to remove the kick plate and go under and check the voltage across the thermistor. By doing this, I'm going to cut my circuit in half. If I have 5 volts across the thermistor, I know power is applied to the dishwasher, and I know that the little transformer is good, and I know that the wiring up to the board is good. But if when I measure the voltage across the thermistor I get a 0 reading, I know that either the board is bad, the transformer is bad, or I do not have power applied to the dishwasher, or here again I can have a wiring problem. My next step would then be to go to the plug that goes to the transformer, and here leave the plug together and go to the back of it and measure between the white and black wires, and this should be your 120 volts coming in. If I have 120 volts here, then I want to go to the other 2 wires and measure the voltage out of the transformer. If I have 12 volts out of the transformer, then I know that the transformer is good. If I get a 0 reading, I know that the transformer is defective. If I get 12 volts out of the transformer, my next stop is the back of the control board. And here I want to measure the voltage drop between pins 1 and 2 of the 10-pin plug. If I have 0 volts here, this indicates to me that I have a broken wire between my transformer and the control board. If I have 12 volts, this should indicate a bad control board, but let's make one quick check just to double check ourselves. The quick check would be to measure between pins 3 and 4 of the 10-pin plug, and here is the 5 volts DC output to the thermistor. If I get 5 volts from here, this would indicate to me that I had a broken wire going to my thermistor and that the test had given me the wrong direction. Now let's go back and follow the other path by saying that when we measured our voltage across the thermistor, we did read 5 volts. Here this would indicate that we either have a bad door line switch, bad control panel, or a bad touchpad. Our next step then would be to go to the back of the control board, and here we want to read voltage between terminal PT1 on the back of the board and pin 10 of the 10-pin plug. This would be the power in from the door switch and our neutral side. If we have 120 volts here, we can eliminate the door switch. And now we have it narrowed down to either the control board or the touchpad. The next step I would do would be to remove the ribbon from its holder and clean the end of the ribbon with a pencil eraser and carefully reinstall the ribbon. I would then test the unit again to see if it would operate. If it does not operate, I would change the control board. If the dishwasher still does not operate, I would then change the touchpad. The reason I would change the control board first is that the touchpad is made up of a series of switches, and usually when it fails will cause just a certain section of the dishwasher not to program rather than keep it from operating completely. The other reason is the touchpad is glued to the front of the control panel, and by removing it you're going to damage it. So if it wasn't bad before you took it off, it's going to be bad once you get it off. Since we talked a little bit about the problem of the control panel only partially programming, let's go ahead and discuss that problem. First, the 2 parts that can cause the problem would either be the control board or the touchpad. And here the first thing we want to do is take that ribbon out and clean it good with a pencil eraser and carefully put it back in place. If this does not correct the problem, then what I would do is change the touchpad. The reason being that the percentages are with you, this is going to be the bad part. After changing the touchpad, if it still does not operate, then I would change the board. There are 2 other problems which can be involved with the board and the touchpad circuits. First, let's talk about the high-end unit that has a display. And here, let's say that the display does not light up. If the display does not light up, we have a possibility of one of two bad parts: the control board itself or the display. The display is plugged into the side of the control board with a 4-pin plug. And here what we want to do with the control panel drop down, start the dishwasher and measure between the two outside pins of the plug. Here we should have 5 volts DC. If we have the 5 volts, the display is bad. If we have 0 volts, the control board is bad. The final problem I can think of in the control panel area would be one that would occur on the Selectronic models. Here the control board has been pre-programmed to operate in normal wash only if any part of the circuit fails. The two parts that are affected in this unit would be the Selectronic control and the control board. Before we do any measurements, let me explain to you that the Selectronic control is actually a variable resistor with stops. The resistance across the complete resistor is 47,000 ohms. Now let's go back and see how we should troubleshoot this problem. First, open the control panel up and unplug the selector control from the control board. Here you're going to find it is a 3-pin operation. The first thing you want to do is go across the two outside pins with your ohm meter, and here you should have 47,000 ohms. If you have 47,000 ohms here, then go from the side of the plug that has the black inked ribbon on it to the center pin. Set the control in pots and pans and you should have 2,000 ohms. In normal wash you should have 10,000 ohms. In short wash you should have 20,000 ohms. And in rinse and hold you should have 30,000 ohms. If your measurements across the control are correct, then you have a defective board. But if your ohm reading is off, you have a defective selector control. Since the control board supplies electrical power to operate all the other components of the dishwasher, the rest of our troubleshooting will basically boil down to seeing if we have power coming out of the control board for that circuit. And if we have power coming out of the control board, then we will troubleshoot the circuit. If we do not have power coming out of the control board, we will condemn the control board. Let's start out with the drain operation, since that occurs first in the cycle. To troubleshoot an electronic dishwasher that's not pumping out, I would remove the kick plate, unplug the electrical plug from the drain pump motor, then set the control panel to a diagnostic mode, and when it reached the drain cycle, I would measure the voltage at the plug. If I have 120 volts here, then I know that the control panel is doing all it's going to do, and I have a problem in the drain pump area. If I have 0 volts here, then I want to go back up and check the voltage out of the control panel. If I have 120 volts when I made my measurement, then what I want to do is make sure that the pump is not restricted, and to do this I'm going to have to disassemble it. After checking for a restriction, if the pump motor still does not operate, then I'm going to have to change the pump motor. Before we leave the drain area, I should mention two things. Both of them have to do with the installation of the dishwasher. First, when the dishwasher leaves the factory, there's a loop tied to the side of the dishwasher that is necessary to have this pump operate. Second, there is a crossover hose between the two cavities of the pump sump, which can be pinched if something is laid underneath it and the dishwasher installed on top of it. Whenever you have a drain problem, and the drain pump's running but you're not getting the water to pump out properly, check for something pinching the hose underneath the sump, or that somebody has taken the loop off the side of the dishwasher. The next thing that occurs in the cycle is the control board activates the water inlet valve. In this circuit we have 4 items that could give us problems. First of all, if we don't get any water coming in, the first thing you want to make sure is that the water supply to the dishwasher is turned on. Then the other 3 components would be the control board, the float switch, and the inlet valve. If we take a quick look at the inlet valve circuit, we find that power comes out of the control board, goes to the float switch, and then to the water inlet valve. What I would do is remove the kick panel and measure voltage between neutral and each side of the float switch. If I do not have any voltage, I would go back to my board and measure power out of pin 8 of the 10-pin plug. Here, if I do not have any voltage, I got a defective board. If I do have voltage at this point, I've got a broken wire going down to the float switch. If I have power on one side of the float switch but not on the other, I have a defective float switch. If I have power on both sides of the float switch, I then know that I have a problem with the water inlet valve. One of the things we probably should talk about at this point is actually how much water should come into the tub. Because of the small amount of water used by this dishwasher, you may get a call that the customer thinks there's not sufficient water in the tub. Here what you need to do is start the cycle, allow it to pump out, and then allow it to fill. At this point, open the door, and the water level should be right at the bottom of the heating element brackets, which is slightly above the filter screen. If the water is below the filter screen, then what you probably want to do is check the water pressure from the house. If that is good, and here I'm talking above 20 psi, then what you want to do is disconnect the water to the inlet valve and clean the inlet valve screen. Once the fill cycle is completed, the main wash pump starts. Here we have two components to worry about. First of all would be the control board, and the second item then would be the wash pump. But let me give you a little advice before we actually go in and test anything. The first thing I would do is go inside the tub, remove the lower spray arm and the filter so I could get down to the impeller of the pump. And here I would see if I could turn the pump impeller. If the pump impeller is froze, I know I have a problem with the motor. If the pump impeller spins easily, then I would remove the kick panel, unplug the motor, set the control board into the diagnostic mode, and when it got to the motor run portion, measure the voltage at the plug. And here, if I have 120 volts, I know I have a problem with the motor. If I have 0 volts, I have to go back up to the control board and measure the output voltage between terminal PT03 and neutral. If I have 120 volts here, I know I have a broken wire between the control board and the wash pump. If I have 0, I know I've got a defective control board. In the middle of the wash cycle, the control board sends 120 volts to the wax motor of the soap dispenser. The wax motor then heats up and in about 30 seconds opens the soap dispenser door. If we should get a call that the soap dispenser door does not open, we need to remove the outer door panel, start the diagnostic test, and measure the input voltage to the wax motor. If we have 120 volts, we've got a defective wax motor. If we have 0 volts, then we have to go back to the control panel. And here we want to measure the voltage drop between pin 7 of the 10-pin plug and neutral. If we have 120 volts, we know we have a broken wire to the dispenser. If we have 0 volts, we know we've got a bad control board. Now let's move into the dry cycle. At the start of the dry cycle, the control board applies 120 volts to the wax motor of the vent valve to open up the vent path, and 120 volts to the blower motor, which is mounted in the vent path to help in the drying. If we look at our wiring diagram, we see that these two components are in parallel, and this is a big help when we're troubleshooting something. This means if one of them works, the other one has to be bad. If both of them do not work, your percentages are that the board is giving you problems. Let's see how we would check that. If both of them do not work, what we would do is go back to our board and go to pin 6 of the 10-pin plug and measure between there and neutral to see if we have 120 volts out. If we have 0 here, we've got a bad board. If we have 120 volts, then we're going to have to go out to one of the components and measure voltage here. If we have voltage applied to the component and it's not operating, then we've got a bad component. Or in this case, since we've got two of them in parallel, we probably have both bad components. This is highly unlikely, and the first thing I would look for would be either a bad board or a broken wire if neither one of them work. The last component we need to talk about is the heater. And here, if we look at our circuit, we find that the heater circuit is made up of the control board, a high-limit thermostat, and the heater itself. To troubleshoot this circuit, I would remove power from the dishwasher, remove the kick plate, and drop the high limit thermostat down and bring it out front so we can measure voltage across it. Then I would put power back on the dishwasher, put the unit in its diagnostic test, and measure voltage between each terminal of the high limit thermostat and neutral. One thing nice about this is we can see the wire that comes over from the heater, so we know that's going to be our neutral side, and we know the other wire then has to be the one coming from the board. If we measure our voltage drop between the side that comes down from the board and neutral, and we have 0, we know that we have a defective board. If we have 120, then what we need to do is go to the other terminal of the thermostat and measure between it and neutral. If we have 0, we've got an open thermostat. If we have 120, then we've got a bad element. The last problem I'd like to go over with you would be the complaint that the dishes are not clean. And here we have a number of things that can cause this. 3 of the most obvious things would be low water temperature, and improper draining. If I received a complaint that the dishes were not clean, the first thing I would do when I arrived at the house is remove power from the dishwasher, remove the kick plate, go in and take the wires off the thermistor, and with my ohm meter measure the resistance of the thermistor. Here we should have about 10,000 ohms. If we're more than about 20% off, I would change the thermistor. The reason I want to do this first is as soon as I add water to the tub, the resistance of the thermistor is going to change, and therefore I can't tell whether it's good or bad. If my thermistor checks good, then what I want to do is put the wires back on the thermistor, reapply power to the dishwasher, and set the dishwasher up for a short wash. Once the dishwasher is filled, I want to check 2 things. First of all, I want to check the water level in the dishwasher, and here it should be up to the bottom of the brackets that hold the heater. If the water level is correct, then my next step is to measure the temperature of the water. And here I should have at least 120 degrees Fahrenheit. If I'm below 120 degrees, then I'm going to have to go to the water heater and increase my water temperature. If the water temperature is above 120, then what I want to do is run the dishwasher. At the end of the wash cycle, I want to remeasure my water temperature. And here I should have an increase in water temperature up to above 136 degrees. If I do not, my temperature function is not working. Since we've already measured the resistance of the thermistor, I would go to the back of the board, and here you want to measure the voltage between pins 3 and 4 on the 10-pin plug, and you should have 5 volts DC. If you have 5 volts DC here, then I would go back to the thermistor and again remeasure my voltage. If you have 5 volts at the thermistor, even though the thermistor checked good, I would replace the thermistor. If you have 0 volts when you measured at the board, then our control board is defective. If the water temperature is above 136 degrees, then what I would want to do is let the cycle complete and check the drain, and here we should have less than 1/4 inch of water down in the bottom of the sump. If we've got more than that, then we've got the crossover hose pinched, or we're having a problem with our drain pump. The disassembly of the timer models and the electronic control models of the precision wash dishwasher are very similar. Therefore, at this time, let's take a look at how we would disassemble the components of the electronic dishwasher that are different than the timer dishwasher. Then at the end, we'll have a review by reviewing an excerpt from the timer model tape. All electronic components, except for the transformer and thermistor, are located in the control panel area. Therefore, to drop the control panel, we will need to remove the 6 screws as we did on the timer model. You should note that if you have a slimline model, you're going to have to remove the outer door panel first. Once the control panel is open, we then can get to the control board cover, and here this is held in place by 4 screws. Remove the 4 screws and carefully lift the control cover off. With the control board cover removed, we now can get to the control board. To remove the control board, disconnect the wires and disconnect the ribbon. The control board is then held to the panel by 6 screws. Remove the 6 screws and the control board will lift off. If we're working on this electronic model, the removal of the control board cover also reveals the back of this electronic control. To remove this electronic control, remove the knob unplug the control from the control board, then remove the two Phillips head screws holding it to the control board, and the control will lift off. The touchpad is probably the most difficult of the components to remove. To remove the touchpad, you need to get to the back of the control board and disconnect the ribbon from the control board. Then take a small screwdriver and start at the corner of the touchpad up, and then peel the touchpad off. To reinstall the touchpad, it's necessary that you clean the glue off the control panel, and here I would use a little denatured alcohol to clean it. With the control panel clean, slide the ribbon through the slot. Position the touchpad on the control panel. Remove the backing from the touchpad and press it down. The transformer is mounted to the drain pump bracket and is held in place by a tab and a screw. To remove the transformer, unplug the wirings to the transformer, remove the screw, and the transformer will lift off. The last of the electronic components is a thermistor, which is located on the bottom of the pump sump. To remove the thermistor, remove electrical power from the dishwasher, remove the kick plate, disconnect the two wires from the thermistor, remove the one Phillips head screw holding the thermistor in place, and pull the thermistor down. With the completion of the electronic components, let's go back and review the disassembly of the timer models by using an excerpt from our original training tape on the timer models.
Performance. While the precision wash system brings a totally new way to wash dishes, you'll find that much attention has been paid to the servicing of this product. Of course, careful attention must always be given by the servicer to observing safe working habits. While working on the unit, only leave utilities hooked up when absolutely necessary for testing. In those cases, be careful. Always be aware of which contacts are hot. You'll find the precision wash system is designed to make your job a little bit easier, quicker, and more efficient. First of all, you'll find a junction box that's 60% larger than previous models, providing more working room. The entire wiring harness has been significantly reduced with 19% fewer connections. The outer door and kick plate can be separated from the unit by removing only two screws. And no wiring. The use of separate wash and drain pumps results in greater reliability, but also makes the system quicker and easier to service. And adjusting the rear leveling legs from the front means the consumer can have a perfectly level dishwasher without you having to go through tedious trial and error. These design factors, implemented solely for the benefit of installers and servicers, address some of the most common difficulties in servicing dishwashers. The product has been designed to require relatively few tools for disassembly. Disassembly of the door, as mentioned before, is quick and easy. Beginning at the top, 6 screws hold the control panel in place. The outer door panel is held in place by 2 screws at the bottom, 2 tabs at the top, and 2 tabs at the bottom. If the control panel is still in place, loosen the bottom 2 control panel screws, then after removing the bottom 2 door screws, the outer door panel will slide down and out. The timer is held in place by 2 screws located behind the timer knob. sure that the plastic sleeve is put back into place when finished. The selector switch is held in place by 2 screws located inside the control panel. The door vent is attached to the inner liner with 4 screws and connected electronically to the blower motor and vent actuator. The vent blower is attached to the top vent with 2 screws and the bottom vent with 4 screws. The vent valve can be removed by simply sliding it upward. Reinstalling it can be made easier by tilting it slightly. The door latch assembly requires a slight change of tools with 2 number 25 Torx screws holding it in place on 2 locator pins. After disconnecting the screws and the wiring that goes to the door switches, the latch assembly can be pulled out. The door switches are held in place by plastic brackets. After pushing the brackets open, rotate the switch upward. Indicator lights are snapped to the lens and spring-loaded against the control panel and are wired directly to the timer and harness. The detergent and rinse aid dispenser is held in place by 6 Phillips head screws. It pushes through to the inside of the tub. Finally, 4 number 25 Torx bolts hold the door liner to the door cans. The door seal is simply pressed into place. It has a white mark that represents the center of the seal. When reinstalling the seal, start with the white mark centered at the top of the door opening. Press it in place from here out. Now we'll move inside the tub. The upper rack is kept in the tracks by 2 rack end clips. To release the upper arm funnel tube, push in at the top of the 2 clips and pull straight up. The upper spray arm is held to the upper spray arm bracket by a plastic nut, which is usually only finger tight. All rack rollers are screwed into the plastic liner with number 25 Torx screws. The upper wash arm water distributor is screwed to the distribution tube. Be sure to save the seal that is located on the outer side of the tub. Moving down to the kick plate, you'll find 2 Phillips head screws holding it in place. You'll find that the heating element is held in place above the tub floor by 2 standoff retainers. After the wiring and the retaining nuts are disconnected, the heating element will lift up and slide off the standoff retainers. The float switch is attached to the float switch bracket, which is screwed to the tub floor. After disconnecting the wiring to the float switch, push the clips open and remove the switch. The bracket is held in place by 1 Phillips head screw. The water inlet valve is held to the front frame brace by 2 screws. After disconnecting the water line, fill hose, and wiring, remove the 5/16 hex head screws. The drain pump is attached to the drain pump bracket, which is screwed to the bottom of the tub by 3 Phillips head screws. In most cases, you only need to remove the pump and leave the bracket. After removing the wiring and hoses, remove the Phillips head screws that hold the pump to the bracket. The drain pump assembly consists of 3 integral parts: the front housing, the impeller and motor armature, and the stator winding. The front housing comes off with a 1/8 turn counterclockwise. The check valve housing also comes off with a simple twist. The stator winding is held to the impeller motor with 2 plastic clips. The drain loop is designed to prevent airlocks in the drain pump. it must always be reconnected. The bottom spray arm can be removed by pulling out on both retaining clips and lifting. The glass trap is designed to be lifted out easily. A quarter turn clockwise will release the spray arm support and it can be lifted off. The filter and soil director are a single unit and will simply lift straight up. The volute cover is held in place by 3 screws. All hoses and wiring that are connected to the pump must be cleared before servicing the pump. The pump housing is held to the tub by 4 rubber tabs. After turning the tabs inward, lift the pump out. You'll need a torque screw head to separate the motor heat shield from the pump housing. The motor and pump impeller are held to the pump housing by the heat shield. With it removed, place a large screwdriver between the housing and the impeller. Force the impeller and motor out of the housing. Do not try to remove them by pulling on the motor or rocking the motor. To remove either the Temp Assure or Temp Boost thermostat, after disconnecting the wiring, remove the screw holding the thermostat in place. To remove the safety thermostat, simply unscrew it from its mount. It should be noted that certain procedures can only be conducted after other procedures have been completed. For instance, the inner door liner cannot be removed unless the control panel, door vent, dispenser and latch assembly have already been removed. That concludes the teardown of the Frigidaire Precision Wash System dishwasher. Thank you for watching this Frigidaire service training program.